Hey, welcome everybody to 9.2, Graphing Simple Rational Functions. So in this section we're going to continue talking about a rational function, and a rational number is a number that can be written in fraction form. A few examples are the number 4 could be written as 4 over 1. The number 3/2 is in fraction form already. In general, a rational function, here's the official way we're going to say it. Our function f of x stands for our function is going to be this equation p of x divided by this equation q of x. So p of x over q of x, and where p of x and q of x are polynomials, so it's got numbers, variables, and symbols with plus and minus signs in between. Where p of x and q of x are polynomials, and q of x is not equal to 0. And then, so p of x and q of x are polynomials, and q of x is not equal to 0, because you can't have 0 on bottom of a fraction. So I want to tell you that today it's called simple because p of x and q of x are both linear. So both of the polynomials we're going to be using in today's graphs are linear, and then in section 9.3 we're going to do some rational function graphs where they're not linear. You know what, I wrote both polynomials, but I meant to write both linear. So both the top and bottom are going to be linear things. Alright, so this one doesn't necessarily have it kind of has a parent function depending on the format. I'm going to give you a graph, and we're going to do a lot more points than you normally would, just so you can see the general idea of what this would be like. So I made a table of values here, and we're going to create this graph. So everywhere every single one of these I'm going to plug in that value for x, and then I'm going to convert it to decimal form because that is going to be easier for our purposes right here. So I got negative 0.25, and this part I am expecting you understand what I'm doing, so I'm going to do this a little quickly. But when x is negative 3, it's negative 0.33. 1 divided by negative 2 is negative 0.5. 1 divided by negative 1 is negative 1. 1 divided by negative 1/2 is negative 2. 1 divided by 0, undefined. 1 divided by 1/2 is 2. And then the rest of these are going to follow this pattern, just what we had before, only positive now. Alright, when I graph this, just do the best you can, but negative 4, 1, 2, 3, 4, negative 0.25, then negative 0.33, negative 1/2, negative 1, negative 2, and then the other side looks something like this. And notice that this section was undefined right here when x was 0. What's actually going to happen is that undefined part gives us a vertical asymptote. So it's hard to tell because my grid lines are so thick, but what's happening is I actually have two pieces of graph with an asymptote in the middle. I'm going to pause, give you some time to get that written down. And there is also actually a horizontal asymptote going on. So note there is a vertical asymptote. And remember, an asymptote is a line that the graph gets really, really, really close to but never touches. There's a vertical asymptote at the equation of the line x equals 0, and there is a horizontal asymptote at the equation of the line y equals 0. A few things that you need to know. This graph is called a parabola, or hyperbola, sorry, hyperbola graph, and each one of these little sides we're going to call a branch. So each section is called a branch. A few other things you need to know. These points are exactly mirrored across from each other, and it will be like that every time. though the numbers might not be the same. It'll always have the mirror look, but the numbers might not be the same because we're going to shift this graph up, down, left, right. And I'll say more in just a little bit. And then let's talk about domain and range. So domain, remember, that is all of the x values that could be used in this graph. And notice that if I made the world's largest graph, actually all the x values are going to be used except 0. So I'm going to say all reals except x equals 0. And for the range, which is the y values, it's very similar. If I made the world's largest graph, all the y's are covered except for at the 0 part. So all reals except y equals 0. All right, all of our graphs are going to look very similar to this. When they give you the equations for the lines, there's two different formats they might give to you. So if you look below, the next part I have is two different equations, format 1, format 2. We're going to do 2 of format 1 and then come back and do format 2. So here's what you need to know about format 1. The horizontal asymptote for format 1, the horizontal asymptote is at y equals k. Y equals k, and the vertical asymptote is at x equals h, but h is actually the opposite of what you see. Just like we've done so many times with h and k, same rules apply, opposite of what you see for h. And I'll explain what I mean with example A. So let's say I'm going to graph A. Now the reason I'm telling you this is for the first part, I did a whole bunch of points. We're not going to make you do a whole bunch of points. So what we're going to do when we graph, we're going to plot our two asymptotes, and then we're going to find two ordered pairs on either side of the asymptotes, and then we'll create our graph. Let me show you what I mean. So first of all, I want to plot my asymptotes. That's going to always be your first step when you're graphing these hyperbolas today. So I'm going to identify my asymptotes using what I just said. Okay, so the k value is the horizontal asymptote, and that is at -1. Notice that it's essentially like the asymptote got moved down 1, just like how a k normally moves things up or down. It moved my regular asymptote down 1. And then when I said the opposite of what you see, that means I want a -3 right there. So that actually moved it left 3 units. And when I say it, I meant it moved the vertical asymptote left 3 units. Now we need to know that our graph is going to look similar to what we just did. Random fact, this has a negative in front, so instead of it being here and here, it's going to be here and here. That's a fact you don't have to have memorized because it'll work out that way when I create my ordered pairs. And then here's what we're going to do. I want 2 x's that are to the left of my vertical asymptote and 2 x's that are to the right of my vertical asymptote, and that's what my 2 ordered pairs are going to be. So to the left of my vertical asymptote would be -4 and -5, and you wouldn't have to pick exactly those 2 points, but they're the smallest numbers I can find that are right next to the asymptote, so mine as well. I'm going to take my equation and I am going to plug in -4. And I just did that right from up here. So -4 plus 3 is -1. So that is -2 divided by -1 minus 1. That's 2 minus 1, which is 1. I didn't really give you a lot of space to write here, obviously. All right, and next, -5 plus 3 is -2. So that would be 1 minus 1, so that would be 0. Okay, so my 2 points are -4, 1, 2, 3, 4, comma 1, and -5, comma 0. So the first part of my hyperbola looks like this. Now, we know because it mirrors, these are just going to go right down here, but let's find the specific points anyways. So my 2 x values to the right of my asymptote would be at x is -2 and x is -1. And again, I wouldn't have to use those 2 specifically, just pick 2 that are to the right of it. All right. So here I go. I'm filling this in. So now I have negative 2 over negative 2 plus 3 is 1. So that's negative 1 minus 1. Okay, so negative 2 is my first point. I'm going and plugging in what I need to for the next one. Negative 2 over 2 is negative 1. And I obviously did something wrong. Yes, this is negative 2 minus 1, which would be negative 3. So negative 2, negative 3, and negative 1, negative 2. Watch that. I made a mistake originally with that number, so I changed it. Alright, there I am. And last but not least, we're going to find the domain and range. Now for you people who are really step-by-step people, let me write this down. Step 1, we plotted the asymptotes. Step 2, you want to find two ordered pairs on each side of the vertical asymptote. Two ordered pairs on each side of the vertical asymptote. Alright, last but not least, let's go ahead and say our domain and range. So, domain is always the x's, and so this time our asymptote has moved left 3 units, so this time our domain is all reals except x equals negative 3, and my range has moved down 1, so all reals except where the asymptote is, which is at negative 1. Alright, make sure you pause the video and write down questions you might have, because first time through that might seem a little confusing to you. We are going to flip over the sheet. You may notice I put one of each type on the front. So flip over your sheet and go to example C. That's what we're going to do next. Alright, looking at example C, horizontal asymptote is at y equals k, so y equals 3. Vertical asymptote is at x equals the opposite of h, so x equals 4. Step 1, plot your asymptotes. Here I go, there is my line, y equals 3. 1, 2, 3, 4. Here is my line, x equals 4. So step 1, plot your asymptotes. Step 2, I want to pick 2 points on either side of my vertical asymptote. So check this out. My vertical asymptote's at 4, so let's say we pick 2 and 3 maybe. And then I'll pick 5 and 6. So 2 that are to the left of it, 2 that are to the right of it. And I'm going to take these, plug them in for y, and solve it. Alright, 2 minus 4 is negative 2. Negative 1 divided by negative 2 is 1/2. Plus 3 is 3.5. So my first dot is 2, 3.5. And at this point, I would like you to pause the video and fill in the rest of the chart. And when you unpause, I will have it all showing. Alright, here's what I've got. Well, here's what I got. I got when x was 3, y was 4. When x was 5, y was 2, and when x was 6, y was 2.5. Now if you got any of those wrong, most common mistake I see is people forget to do that bottom part first before using the negative 1. So that could have been your mistake. Here's what my graph looks like. My domain then is all reals except my vertical asymptote, and my range is all reals except my horizontal asymptote. Tune into the next video to hear the other type of graph and to do some practice with E and F. Thanks for listening.